basic setup and parts. So here's what I'm going to give you right now that I'm at the high school. And knowing your knowledge about the streets of Del Mar, could you get me to the middle school as an end goal? Give me directions. Okay, anybody want to start it off here? What do I do? I'm at the high school. What do I do here? You don't need to get too detailed, but what do I do here? I need to go down. Okay, well, I could take a left or a right out of the high school here, and I'd be on Delaware, right? Do you want me to take a right on Delaware? Okay, I took a right. So straight until Kenwood. All right, still listening. Okay, still listening. What do I do on Kenwood? Okay, where should I look for the middle school? Because I got... Okay. And then I finally got there. Okay, this is going to be the basic setup of a proof where I am going to give you some information, some geometry facts. Two lines are perpendicular. This ray bisects this angle. I'm going to start you out with some info. Then what you have to do here, wasn't this stuff you already knew? Right? So you're going to have to use, vertical angles are congruent. Linear pairs are, linear pairs are supplementary. You're going to have to use all these geometrical facts and knowledge that you have to get me to what I'm asking for at the end. And it's almost like a puzzle. You got to put it in the right order so that I get to the proper place at the end. That's what these proofs are going to look like. And we're not going to start our first one until tomorrow. All right. But everyone see the basic setup of what I'm going to ask. I'm going to give you something. All right. That's true. You're going to say, okay, I know this about perpendicular lines. I know this about a bisector. I know this about supplementary angles. You're going to put it all in the correct order, all those facts, to get me to this end goal of whatever I ask you to prove. Matt, go ahead. Because I'm assuming here, good question. Because this was the first thing. I'm at the high school. Usually whatever I give you is going to be the first step in our proof. Okay? All right, good question. I'm at the high school, and this would be 6. Okay? All right. Everyone all right on this basic setup? All right, hopefully that wasn't too confusing, but I just wanted you to get an idea of where we're going with all this. But all this now will be geometry facts. Okay? Yep. Okay, that's a great point. How many steps is fine? Well, let me ask you guys, is there a different way other than what you told me here I could get to the middle school? Okay, and that's the same thing with proofs. There's different ways to get to the end goal. So I don't know if it's going to be 4 steps for you and 6 steps for somebody else. Whatever gets me to that end goal in the correct order too. Okay, so there's all different types of ways. All right, so here's what we're going to practice today, and it's not too long. Most of the time will be dedicated to you guys in your group working on the homework, is I'm going to give you a fact today. Like I'm starting at the high school. I'm going to give you a fact. And what I want you guys to do is spit out as many facts as you can give me. All right, that's what I want. I'm going to tell you something about a diagram, and you say, oh, because I know this, and from Unit 1, I know that vocabulary term, this is what's happening. All right, first thing. Let's try to mark our diagram as much as possible before I write anything down. All right. So look, what did I give you in here? Segment AB. Anybody remember this symbol from Unit 1? Perpendicular. Got to know the terminology. All right. Segment AB is perpendicular to segment BC. Okay. What do you know now then? Because I gave you that, what do you know? And I don't want to write anything down yet. I just want to mark my diagram. What do you know now? Okay. If those two are perpendicular, what do we know? Let's open it up to everyone. I appreciate the hands. Just want to hear from some more people. 20. What do I know now? Nope. Well, nope. That doesn't tell me they're congruent. We talked in Unit 1. I know that's what they gave me. But what do perpendicular lines do? This is why I showed everybody in Unit 1. Do you remember what perpendicular lines do? Somebody just yell it out. They form right angles, don't they? All right, so where can I put a right angle symbol on my diagram? Angle B. And why did you put one there? Because what did I give you? They were perpendicular. So now we're going to start writing these thoughts in an organized fashion. And the way we're going to write our thoughts down, and this is the setup of every proof, is we're going to have a statements column and we're going to have a reasons column. And I know some of you are amazed by my setup here, how I did reasons into the column. You can even connect the S's if you want to be fancy. Our first statement should probably always be our given. Whatever we were given, I'm always going to put it in my first statement. So AB perpendicular to BC. Here's where you're going to probably have the toughest time at the beginning of this unit. Why is that true? It was given to me. You're darn right, Vince. It was given to me. So what am I going to write for my reason? Not it was given to me. I'm just going to write given. What'd you mark on your diagram a couple minutes ago? So we are saying that angle B, and you guys can start doing the shorthand here, the angle symbol. Angle B or angle ABC or CBA, however you want to name it. Angle B is a right angle. Okay, how'd you know? I had a ton of hands go up. Why were your hands up? How did you know that that was a right? And just talk to me. We'll write a reason down, but just talk to me. How did we know that was a right angle? Number one, how did we know that was a right angle?
When it's perpendicular, it always comes right angle.
Okay, that is correct. And no offense, Meg, but do I want to write all that down? Probably not. You don't either, probably, what just came out of your mouth. All right, so let's just shorten that real quick. Perpendicular, and I can start using the symbols here for shorthand. That's fine. Perpendicular lines form, anybody want to finish it? Perpendicular lines form right angles. Now, do I need that wording every time? No. If you want to write it all out, two perpendicular lines form a right angle, that's fine too. All right, that's what I said. The proofs can be written in different ways. Just what I write up there isn't it and only it. A lot of room for interpretation. All right, is there anything else you want to put up? I'll listen. Is there anything else you want to put up now? We know that they're perpendicular. We now know angle B is a right angle. Anything else?
Triangle ABC is a right triangle.
We could put triangle ABC. Okay, I'll put it up there, sure. And what you guys will start to notice when we get into an actual proof is you'll need some of this and you won't need the rest. Like maybe I'll need that there's a right angle, but the proof has nothing to do about a right triangle, so I wouldn't have anything to do with that. All right, you're going to have to pick and choose what you need. That's the toughest part. So triangle ABC is a right angle. Oh yeah, right triangle, sorry. What would be a good reason? Why is it a right triangle? Right triangles have? Okay, that's fine, yeah. Oh, anything else here? I don't want to go too deep here. I want to get to other examples. So, Meg? Okay, I could put, this will probably be the last one, just because we could keep going on for a long time. So the measure of angle B equals 90 degrees. How do we know that? How do we know it's 90? 90. Caitlin? Right angles equal 90, right? Or definition of a right angle, right? So I'll right angles equal 90. I'll write definition. I'll abbreviate it DEF, definition of a right angle. And I'll just stop there. There could be more. For instance, anybody know anything about angles A and C? We have a term for those. I don't know they're congruent or not. I don't know they're congruent, but I do know that they add to what? If that's already a right angle, there's 180 degrees in every triangle. A and C have to add up to what? 90, not necessarily congruent. I don't know that because there's no markings, but they add up to 90, so I can call them complementary. So there's another one you could have written down. Okay. Everybody good up here? Look at that. One given. Look what we got from that. But what? Does everybody see that the order mattered here? Could I have put in this statement before this statement? Could I have said it was a right triangle before I said I had a right angle? No. Does everyone see that? So the order does matter. It will matter. All right. And just like down here, I couldn't say angle B equals 90 until I said what? It was a right angle. Okay. So this kind of had to go first. And then I could have flip-flopped these if I wanted to, but that had to go first, that it was a right angle. We all good? Questions, comments, any concerns? That was just one. All right, let's try another one. Oh, bisector now. Bisector of angle ABC. This is going to be noisy. Sorry, I don't know. Oh, no. Squeaking a lot yesterday. Okay, mark your diagram first. Don't write anything down. Mark your diagram. If you know that BD is the bisector of ABC, we have talked about this term last unit, what a bisector does. Okay, what markings can you put on this diagram right now knowing that's a bisector? Let's hear from 16. Arc marks, yep. Where? Specifically where? Ooh, line. Nice job. Nice job. Everyone agree? Okay, we'll write down Y in a second. I don't think there's any other markings I can put on here. I can't put congruent symbols on rays, so. All right, so let's write our thoughts out here. So the first thing we knew was ray BD bisected angle ABC. And we know that's true because that was given. Just getting that habit, that's usually our first step in every proof. BISECT. Bisect. Plainly, no, there's not. Please do not make up, on that note, please do not make up your own abbreviations either, your own hieroglyphics. Whatever I use up here on the board is acceptable, okay? But you start making up your own, no go. All right, what did we mark on the diagram now? We marked angle ABD congruent to DBC. How did we know that? That is one true fact. How do we know those two angles are congruent? Just talk to me. We'll write it down in a certain way in a second, but just talk to me right now. 19, how do we know that? And you know the definition of a what? Of a bisector. That's what a bisector does, cuts it in half. So all I'm going to put here is definition of a bisector. If you actually want to give me that where it cut the angle into two congruent angles, that's fine. Definition of a bisector will be all right. Okay, anything else you want to add to this that we know it's true? I would maybe put one more thing I'm thinking about, but I'll listen to anything. I'm open for anything. Anything else you know is true now.
ABD is equal to measured angle DBC.
Okay, so you're going to put the measure in there? instead now that they're congruent, right? You're going to say they're equal in measure, which is true, but the congruent part there takes care of all that for me. You're not wrong if you wrote that down, that the measure of ABD is equal to the measure of DBC. Just the congruent part takes care of that for me. All right, so I'm not going to have you guys write all these extra steps there. Anything else before I add in mine? Desmond?
Measure angle ABD plus DBC is equal to ABC.
Okay, so you're telling me I add up the two smaller ones, I get the bigger one. I'll write that in. Yeah, I like it. Okay. So angle ABD plus angle DBC equals angle ABC. Hey, you know that's true, because I got to write something down why it's true. What'd you do to the two? I think you're overthinking it. 2 angle addition. How about that? Angle addition. All right. I'm going to write one more in. Angle ABD is equal to blank angle ABC. Anybody want to fill in my blank there? Fill in my blank. Go ahead. What do we got? Half. Yep. How do I know that's true? Another definition of a bisector. Yep. Okay. And we could, could we do another step and instead of ABD, substitute in DBC? Yeah, we could. Let's just hold the brakes here. All right, hold the brakes. Questions? All right, next one. Ooh, sorry, kids. What did I not provide for number 3? A diagram. Can you make segment AB with midpoint M on there for me? That wasn't, I didn't do it. I did do it on purpose. Okay, can you mark your diagram with anything here? 29, mark anything? Where? Oh. Okay, let's write our thoughts down. We'll go a little quicker now that we're picking this up. Okay, write what you marked on your diagram. That should be probably step 2 is whatever you marked on your diagram, write it in your statements now. So we just said what? That segment AM is congruent. Start using the congruent sign, not the equal sign. AM is congruent to MB. How do we know that was true? Why'd you guys tell me to mark that so fast? You know what a midpoint is, right? Cuts it into 2 congruent segments, so we know the definition of a Anything else you want to tell me?
Line AM equals half of the line AB.
Good, you guys. As you see bisector, you see midpoint, things are being cut in half, right? So I could say that AM equals half of AB, or if you want to say MB instead of AM, that's fine. And again, how do I know that's true? Definition of a midpoint, yep. And I'm not going to write it down, but could you say AM plus MB equals AB, segment addition? Sure. All right, instead of angle addition, segment addition. Good. How do we feel about this? Because I'm going to throw a little wrinkle in it for this last one. Anything? Okay, here you go. Last one, and then you get to go on your own here. I didn't give you much. I haven't used the word bisector, midpoint, a fancy vocab term we talked about in Unit 1. But I am telling you that line WR and line should be lines, huh? W or IE intersect each other. And you should be able to spout out a bunch of facts here. Those are two intersecting lines. Two intersecting lines. What do you got, Captain? One thing. How do you know that? Don't tell me if your answer is because it looks like it. I got a right angle symbol anywhere. Do I have perpendicular symbol anywhere? Okay. And I'm real glad you did that, because that's a point I needed to drive home today. Just because it looks like it is not a reason that will ever show up. All right, for you. All right, don't tell me because it just looks like it. All right, go by the vocabulary, or in this case, just the diagram here. Just the diagram. Anything at all? What do we got, Connor? Okay, say it again. RSE and these two? Probably should do a little darker. Correct. Correct. I'm not going to ask why, because I'm going to write it down in a couple minutes. More. You can tell me more, Vincent, more. Yep. What should I put here now? Because not all four are congruent, so I don't want to put one arc mark. Yeah. Okay, hold your thoughts. Hold your thoughts. I just want to get this down here. I don't want to forget about stuff that we've already said. Okay, so the only thing I was given is that those two lines intersect. Okay, we just were told that angle WSI was congruent to ESR. Again, you can name them differently if you want. Okay, how'd those guys know that? How we know that? Term from Unit 1. A term from Unit 1 we have. What do you got? 20. Remember any term from Unit 1 for those two angles? Okay, these two angles we called what in Unit 1? Opposite each other, formed by two intersecting lines. Vertical. And then we found a special fact about vertical angles. What were they? So here's what I'm going to write. Vertical angles are congruent. Check your self-respect. Did you spell vertical right? Check your self-respect. CLE, get it out of there. Okay, why are these two congruent? Okay, they're also vertical. So in that case, I'm not going to have you write a separate step if it's got the same reason. So right underneath this statement, I'm going to put the other pair that are vertical. There's no reason to write another statement when it's going to have the same reason. So angle WSE is congruent to angle ISR. So if you run into that where in a proof you had the same reason, you can write the same statement together. All right. Is it wrong if you write them separately? No. Are we okay so far? Because we're going to start talking about some more facts here, because there's a lot more you could tell me there. All right. I got the vertical angles congruent. There's also other types of angles up there.
Angle WSE is supplementary to WSI.
WSE supplementary to WSI. Everybody agree? Yeah, everybody agree? Okay, well, I'm going to ask you why in a second if you agree. So angle WSE and angle WSI are supplementary. And if you want to abbreviate supplementary, I'll allow you to do SUPP, sup. That's what's up. Why? Why? And specifically, I'm looking for vocabulary from the first unit here. Why they're supplementary. What do we got? And what do you know about, what's the fact we wrote down about linear pairs? So linear pairs are supplementary. Yep. Everyone see us using the theorems now I showed you from unit 1. Linear pairs are supplementary. Now, I don't want to, I know I could do these two angles, these two and these two. We could all write them in step 3. I know that, saying they're supplementary because they're linear pairs, but I'll hold off. All right, just so we don't have to do more writing. Yes, Meg?
The measure of angle ISR and the measure of angle ESR add up to 180.
Because you know that definition of supplementary. That's why they equal 180. Okay. All right, more, go ahead.
Well, I was going to say,
Yep.
you say that they're adjacent.
You could say that too. Definition of adjacent, that's fine. Okay, yep, that's fine too. All right. What I'm showing you guys is stuff I know is going to come up on proofs in the future. Like, we're going to be using vertical angles are congruent a ton. We're also going to be using linear pairs or supplementary a ton. Okay, so don't think because I don't write what you're telling me down, don't, I'm not trying to bag you or make you feel bad. It's just I know this is the stuff we're going to use in the future. Anything else before I let you go on your own? Try to get maybe 2 or 3 things down after you're given, okay? I'm not looking for a ton, maybe 2 or 3. If you can only write the given and one other thing, okay, that's fine. That's fine. Okay, if you want to call me over and let me take a look at it, how's this look? How's this reason look? Let me know. Talk it over in your group. And you will not find an answer key for this because you may see something that I don't and vice versa. Or I may have a different reason, but yours is good too.